Hello everyone. Today we're going to be looking at how to calculate mass from a balanced equation. This is a topic that you see in stoichiometry both in iGCSE and IB chemistry. So on the screen we have a balanced equation of complete combustion of ethane to produce CO2 and water. Now in this video we're going to be using the equation N equals M over MR. So to explain what each of these parts is, N is moles. Mole is a quantity in chemistry, which means that there are a specific amount of particles. So 1 mole stands for Avogadro's number, which is a big number, 6 times 10 to the 23rd power of particles. So if you have 1 mole of a substance, then that means you've got this number of particles. So this is the value N. M just stands for mass, and MR stands for how many grams a substance has per mole. Okay, so let us hypothetically say that ethane we have 3 grams of. And let's see how we can figure out how you can find the mass of, for example, CO2 produced or water. So using this equation to find moles, we've got 3 grams of ethane. We also need to find the MR of ethane. And to do that, you need to look at the periodic table. For each element, there is an MR stated, or an atomic mass. So we have 2 carbons in the equation, and each of them weighs 12 grams per mole. And we have 6 hydrogens, each one weighing 1 gram per mole. So overall, ethane weighs 30 grams per mole. Now, if we plug in all the values we have in the equation, we have N is equal to 3 grams divided by the molar mass, 30 grams per mole. So 3 divided by 30 conveniently gives us 0.1 moles. Now, this is where usually confusion occurs for students. So this balanced equation is telling us the ratio of the different reactants and products. So in front of ethane, there's no number, which is equivalent to saying there's one of them. For every 1 ethane molecule, we make 2 CO2 molecules. So the ratio is 1 to 2. So hypothetically, if we had 1 mole of ethane, we should make 2 moles of carbon dioxide. We know from our calculation below that we only have 0.1 moles of ethane. So therefore, we should make 0.2 moles of carbon dioxide because of this 1 to 2 ratio. Okay, so we've got 0.2 moles. Now, how can we convert that into mass? To do that, we use this equation again, and we rearrange it to find the mass of CO2 produced. So to do that, we also need to find the MR. So the MR of CO2, if you take the values from the periodic table, carbon is 12, each oxygen is 16, and that ends up being 44 grams per mole. Now to find the mass, you rearrange this equation at the top. So mass is moles times MR. So we have 0.2 moles multiplied by 44 grams per mole. And we end up with 8.8 grams. So this method has shown us that if you start with 3 grams of ethane, you will end up with 8.8 grams of CO2. Now, if you just look at these two numbers in isolation, it seems like it is not balanced. However, if you calculate the rest of the masses, you will see that the amount of mass on both sides is equivalent. And for this, please watch part 2.